Hello everyone, welcome to the video on antiviral drugs. I will cover medicinal chemistry 3 aspects of antiviral drugs unit. In this video, I will explain about anti-herpes agents, anti-influenza agents, anti-HIV agents, their structure, nomenclature and synthesis. This is my YouTube channel. You just type in my name G. Sai Rajesh, you will get the videos. If you like the videos, do subscribe and share. Let's get into the topic. Now see, there are 3 major antiviral drug categories are there. Anti-herpes agent, anti-influenza agents and anti-HIV drugs or retroviral drugs. In the syllabus, these drugs are given amantadine, rimantadine. Amantadine hydrochloride, rimantadine hydrochloride. Both of them are anti-influenza agents. And then idoxuridine, trifluridine, acyclovir, ganciclovir. These drugs are known as anti-herpes virus drugs. See, idoxuridine, trifluridine, acyclovir, ganciclovir. So you have big list of antiviral drugs are there, but in the syllabus few drugs are given. And then comes anti-HIV drugs. Anti-HIV drugs like zidovudine, didanosine, jalcitabine, lamivudine, loviridine. All these drugs belong to nucleoside reverse transcriptase inhibitors. Look at them: zidovudine, didanosine, jalcitabine, lamivudine. And then comes delaviridine. Delaviridine is non-nucleotide reverse transcriptase inhibitor. And then you have ribavirin, saquinavir, indinavir, ritonavir. All of these virs belong to protease enzyme inhibitors. Let me give a brief introduction about these anti-HIV drugs. See, HIV can be treated by inhibiting enzymes like reverse transcriptase, protease, integrase, and there is another group called as entry inhibitors. So these enzymes like reverse transcriptase, protease and integrase are essential for viral survival, especially the reverse transcriptase enzyme. So by inhibiting reverse transcriptase enzyme, viral DNA cannot be synthesized. In fact, see, it is called as reverse transcriptase. The reason is virus can make its DNA from RNA. So it is opposite to normal transcription. It is DNA to RNA. So it occurs in the reverse manner. From RNA it synthesizes DNA, hence it is known as reverse transcriptase, and it is also known as retroviruses. So by inhibiting this enzyme, you will inhibit viral proliferation. In that, 2 classes are there: nucleoside reverse transcriptase inhibitor, non-nucleoside reverse transcriptase inhibitors, NNRTS. And then protease is an enzyme essential for protein development in the virus. Whatever the proteins are formed, they are matured with the help of protease enzyme. By inhibiting that enzyme, protease enzyme, the viral protein maturation is inhibited, again multiplication is inhibited. Entry inhibitors, viral entry itself is inhibited by using these drugs. Integrase, viral DNA is integrated to human DNA, and that integration is inhibited by these classes of drugs. All these things you will be reading in pharmacology, but in medicinal chemistry only few drug details are there. Let us see the chemistry aspects of these drugs. Now see, this is guanosine. Understand this one. This is a nitrogen base known as guanine. When guanine combines with a ribose sugar, it is called as guanosine. So this is guanine ring, this is ribose. Now look at the structure of acyclovir, which is widely used to treat herpes infection. Now see, this ribose nucleus, if this part is removed, you get this one. Look at them. Everything is same. You have a guanine nucleus is there, and the ring is broken down. That is the reason why it is called as acyclo, without cycle. So this part is missing. Now because of this structural similarity, this interfaces with viral DNA replication and inhibits viral DNA polymerase enzyme. In viral DNA polymerase, acyclovir will goes, but it inhibits chain elongation, and that is what is the mechanism of action of majority of antiviral drugs. Now let's look at the structure of this acyclovir. Just now we have seen it. See, to make you understand, this one is given in this shape, so that you will see the similarity between a ring and this acycle, cycle and acycle. But you can write it down as a straight chain one. When you see the nomenclature, look at them. The numbering starts from here: 1, 2, 3, 4, 5, 6, 7, 8, 9. This is what is the numbering is. Now see, 2 amino at second position, amino group is there. Now at 9th position, this substitution is there. What is the substitution? 2-hydroxy ethoxymethyl. So So at second position you have a hydroxy group is there, and this is ethoxy and this is methyl. And purine 6-1 at sixth position, one a ketone group is there. Simple. 2 amino at second position, amine is there. At ninth position this substitution is there. Purine ring is there, and at ninth position a ketone group is there. Hence it is known as, at sixth position a ketone group is there, so it is known as 6-1. Now let us understand the synthesis of this one. So it starts with by taking that purine nucleus with a 6 ketone. Now look at them. So with 6 ketone and 2 amino group. 2 amino, 1 purine, 6-1 is the starting material. And what is the side chain is required? Side chain, to add that side chain, 2-chloromethoxy ethyl benzoate is taken. Now the chlorine, this hydrogen goes out as HCl, it goes out as hydrochloric acid, and the side chain attachment occurs. Now the benzoate ester 1 is removed by using a base, a very simple one. Again, in the previous classes I have explained about an approach called as retrosynthesis. Only 2 fragments are there. This is one, this is the second one. And you need to understand how the substitution can be attached to this ring. So this is what is the synthesis of acyclovir is. Now we need to know the remaining drugs. See, most of the drugs are derivatives of guanosine. So you have guanine ring is there with ribose sugar. So when you remove this ring part, it becomes acyclovir. Now to that, if valine amino acid is attached, it becomes valcyclovir. Now if the complete chain is removed, complete ring portion is removed, it is acyclovir. If partial removal of ring is there, say look at this, ganciclovir, partially this part is removed. You can see here, this is called ganciclovir. If the ketone here and oxygen here is removed, it becomes famciclovir with ester derivatives. Whatever it is, you need to understand this one. All of them are nucleoside derivatives which will interfere with the DNA polymerization of virus. So DNA chain elongation is inhibited, cell multiplication is inhibited. Now these drugs are antiretroviral drugs. Antiretroviral drugs. So these drugs are especially inhibit reverse transcriptase enzyme inhibitors. So reverse transcriptase enzyme inhibitors, we have 2 classes are there, nucleoside and non-nucleoside. The reason why it is called as nucleoside is all of them, they resemble like nucleosides, hence it is called as nucleoside reverse transcriptase inhibitors. You need to understand certain things. Look at the structures. See, zidovudine is known as AZT. AZT means azidothiamidine. Now understand this one, thymine, thymidine. This is thymine. When it is with ribose sugar, it is thymidine. But azido means N3 group. This N3 group is present at here. Hence it is known as azidothiamidine. It is a derivative of thymidine. Now look at this other one. Didanosine is known as DDI. Dideoxyinosine. Now inosine is nothing but when you have 2 hydroxy groups here, it is called as inosine. If you remove these 2 hydroxy groups, what happens it becomes dideoxy. So you are removing 2 oxy groups, hence it becomes dideoxyinosine. Now similarly, jalcytabine is a cytidine derivative. See, this part is cytosine. And you remove 2 and 3 dideoxy. Here if hydroxy groups are removed, it becomes dideoxycytidine. Again, stavudine. This stavudine is again a derivative of thymidine, like zidovudine. Similarly, lamivudine is also derivative of cytidine. So all of them, you can see they are nucleoside derivatives, hence they are known as nucleoside reverse transcriptase inhibitors, and all of them, the mechanism of action is they inhibit DNA polymerase of the viral enzyme. If this DNA polymerase is inhibited, what happens? Where the DNA elongation is inhibited. Now the other 2 drugs which are given are amantadine and rimantadine. See, both of them they are known as viral entry inhibitors. Viral entry into the cell is inhibited by these drugs. Now see, when you see the name amantadine is adamantane 1-amine. See, adamantane is this ring. In fact, this is a fusion of 3 cyclohexane rings. It is made up of 10 carbons, but it appears like it is fusion of 3 cyclohexane rings. Now rimantadine, adamantanyl, ethane amine. You have ethane amine substitution is there. So this is rimantadine. Both of them, they are viral entry inhibitors. So these are all the important drugs which comes under antiviral drugs. Thank you for watching this video. If you like the video, do subscribe and share.